Bismillahirrahmanirrahim. Assalamu alaikum student. Hopefully you are fine. This is our new topic for today, that is the variation of parameters. Variation of parameters. And this is our lecture number 13. Here the topic is variation of parameters. Before developing its methodology or defining its methodology, first of all I revise some previous method that we are so far used. So far we are using number one with constant coefficients, and number two with undetermined coefficients. These two methods so far we are using, that we use so far. Number one is method with constant coefficients and with undetermined coefficients. So where we use these two methods to solve the second order linear differential equations. Method 1 is used to solve homogeneous second order linear differential equations, while the method 2 is used to solve the non-homogeneous second order linear differential equations. Here in method number 1 we just only find the characteristic solution. We find only the characteristic solution, which is based on the nature, the roots of the nature, that you know that the nature of the roots are of three types. And in method number 2, that is used for solving the non-homogeneous equations, there are certain restriction imposed on finding the solution by undetermined coefficients. There are certain restriction imposed on finding the solution by undetermined coefficients that are their forcing function. So far you see here the forcing function contain only the algebraic terms, trigonometric terms, in which you see their sine and cosine, and no other than this, these two. And the third one is the exponential function, So and the examples of these methods are where the algebraic functions used, where the forcing function used these types of functions. Here the examples are d square plus 2d plus 1 into y is equal to e raised to the power x. This is our second order linear differential equation in which the forcing function is an exponential function. Number 2 is d square plus 9 into y is equal to sine of x. It is our trigonometric function. The third one is, that is here we use an expression of algebraic terms, based on algebraic terms. And the fourth one is in which we use their combinations, mean exponential, the product of exponential function and trigonometric, and exponential function and algebraic terms, and exponential, algebraic and trigonometric. In this way, there is another method that is used instead of undetermined coefficients. There is another method that we use instead of undetermined coefficients, that is called the variation of parameters. This method is much more flexible and easier to use. This method deal very well when the forcing function is any type of the function like exponential, algebraic, trigonometric and logarithmic. In undetermined method, there is no logarithmic function you use as a forcing function, and in trigonometric function you use only sine and cosine. Remember this. But here we use any type of trigonometric function: sine, cosine, secant, cosecant, tan, tangent, tan, cot. So variation of parameters extend to linear partial differential equations What we say, variation of parameter extends to linear partial differential equation as well, especially to non-homogeneous, or we say inhomogeneous. Inhomogeneous, both are the same. In homogeneous problems for linear evolutions like heat equation, you are very familiar with this heat equation. I am in our starting lectures or initial lectures, in which I tell you about the heat equation, the wave equation and the vibrating plate equations. And inshallah ta'ala later on you will see such type of equation and how you see the vibrating plates equations are what is meant by the vibrating plate equations and damping motions or simple harmonic motions. So we are only dealing with ODE, ordinary differential equations. Not we are interested here in partial differential equations, because our course relate with the ODE, not with the PDE. So somewhere we touch this concept, partial differential equation, and then we solve our problems. So methodology of variation of parameters. Methodology of variation of parameters. Let we have a differential equation. Let we have a differential equation. Its general form is d square y over dx square plus p of x dy by dx plus q of x into y is equal to f of x. You know this equation, the general form of the second order linear differential equation very well. So we know that p of x and q of x both are the functions of x. Both are the functions of x. Whereas the general solution of this non-homogeneous second order linear differential equation is concerned, whereas the general solution of this non-homogeneous second order linear differential equation is concerned, it is based on two types of solutions. You know also that is the first one is the characteristic solution. That is called the characteristic solution, or we say the auxiliary solution. Characteristic solution or auxiliary solution, which is based on the nature of the roots of the differential equation. Which is based on the nature of the roots of the differential equation, and it is represented by YC. And it is represented by YC. It is same as we performed in the constant coefficients and undetermined coefficients. The procedure is same. Procedure is same. These are the following. Just for your reminder, I am stating here. Number one, if the roots are real and distinct, if the roots are real and distinct, then you got this type of solution. YC is equal to A e raised to the power m1x plus B e raised to the power m2x, where m1 and m2 are the real and distinct roots. Real and distinct roots. If the roots are real and repeated, then we seek such type of solution. YC is equal to A plus Bx into e raised to the power mx. This m represents the root that is real and but in repeated form. The third one is if the roots are imaginary or complex in nature. If the roots are imaginary or complex in nature, then you get such type of solution in which YC is equal to A cos mu x plus minus B sin mu x, then e raised to the power lambda x. Here what is mu? Mu is the imaginary part, represent the imaginary part, while lambda represent the real part of the complex number. Whereas the particular solution is concerned, number two, whereas the particular solution is concerned, it is based on the solution of characteristic solution and defined as. It is based on the solutions of characteristic solutions and defined as yp is equal to y1x u1 of x plus y2 of x u2 of x. These two are the solution that we use this y1 and this y2. These are the solutions that we obtained from the second order linear differential equation. As it is second order linear differential equation, so it produce only two roots. So you see here where this u1, what is this u1 and this u2? This is, what is this u1 and u2? u1 is equal to minus y2 minus integral y2 of x f of x divided by w y1 y2 dx, and u2 is equal to y1 of x f of x divided by w y1 y2 into d of x. Now what is this w is? What is this w is? W is defined as in this way. It is the determinant. It is the determinant of y1 and y2, and this is called the Wronskian. It is called the Wronskian determinant. It is called the Wronskian determinant of this matrix. Y1 and y2 are the original solution of the which we got from the characteristic solution, and y1 and y2 prime, y1 prime and y2 prime are their respective derivatives. Wronskian is named after the Polish mathematician. Wronskian is named after the Polish mathematician and philosopher Joseph Hony Wronski from 1776 to 1853. So after this mathematician, it is named as, this thing is named as Wronskian. So now we see so in this way we find these two. Here we use the value of you see again here we use the value of u1 and u2. Here we find the value of u1 by this procedure. We substitute here the value of y2, and then this is this f of x is called the forcing function, and w of y1 y2, this w is called the Wronskian. So after finding the Wronskian, we substitute its value here and compute u1. Similarly, when you compute u2, you use y1 and then it is multiplied with the forcing function and divided by the Wronskian. So in this way you calculate u1 and u2, and then you substitute their values here. Yp is equal to y1 of x, u1 of x plus y2 of x, u2 of x. So in this way we find our yp, and then we find our general solution. How we can find the general solution? That is based on a characteristic solution and the particular solution. Inshallah Ta'ala, we will meet in our next lecture with practice question and with some examples. Till then, take care. Allah Hafiz.